Okay, so today we're still going to be looking at finding the missing side of a triangle, but what we're going to do is we're going to use trigonometry to find a missing side instead of Pythagoras theorem. Okay? Now, you've got to know the difference about when to use which one. So be careful because they're going to be mixed together when you do your homework and when you take the exams. Remember that for the Pythagorean theorem, that's used when you know two sides. Okay, so that third one is missing. Okay, so it's pretty straightforward. So it's always sides. A, B, C. It's always sides. Okay, so the sides are the key there. But we're going to use trigonometry when you know one side and one angle. Now that's for today. Now we will be working when we have more information, but this is just when we're looking for missing sides. These are the processes. Later, we're going to be looking for missing angles and some other things. That's going to mean we're going to have to expand what we do with our trigonometry. But first, we're just going to start with the most basic thing, and that's when we know one side and one angle. Now, before we can use it, we need to talk about what are called the trig functions. So I'm going to pause so you can write this down a bit. Okay, so we're going to use the trigonometric functions or formulas. So there are three of them, and they're used when you know an angle. And in the beginning, we're just going to use a generic symbol for angle, and that is this little theta. Okay, so it's just the Greek letter theta. It doesn't matter. It doesn't mean anything, but when you see that, that means some unknown angle. So let's look at a triangle. Again, it has to be a right triangle, so you're still going to see that there, which means that could be your angle, okay? But usually, you're going to have some little angle, and they're going to call it theta. They usually put it inside, but I drew it too closely. Now, we need three... Oh, so I'm sorry, don't put that down. We need to label the sides. And this is the key to everything. The first label is we need the hypotenuse. Well, that's easy. It's always the one directly across from the angle, from the right angle, and, excuse me, and it's always the longest slanted side. So that one's easy. Then we need to look at the angle and find the adjacent angle, or the adjacent side, or to the angle is what it should be, ready? Now, when you're talking about the adjacent side, adjacent means right up against it, right? So in this particular case, our adjacent side is this side. So that would be the adjacent side. And again, it has to do with the angle, our angle theta. Not the 90-degree angle, but our other angle. Okay? So adjacent just means next to. And then finally, we need to find the opposite side. And that's opposite, again, to the angle. So if you look opposite the angle theta, that's this side. So we have hypotenuse, we have adjacent, and we have opposite. And you have to be able to understand how those are labeled before you can do any other work in this section. So we're going to go to the exercises and just kind of look at a couple of these. They're going to give you some where all they're asking you to do is label them. Okay? All right, so let's go to the book. Oops, that's not the book. Here we go. So here they're just discussing the labels. There you see your theta here in the corner. You see your angle theta. You see straight across from it is the opposite, and that's usually just abbreviated with a big O. Here, the one right next to it is called the adjacent, which we use just a capital A for, and the hypotenuse, which is always across from the right angle, that long slanted side, is labeled H. Okay, so we're going to look at how we can just label them, and that's all we're going to do in the beginning. So we're just going to look at a few of these, and I'm going to have you do a few of these. You don't have to do them all. So if you look at one, the key is always the angle that you're working with. Then the angle straight across from it is the opposite. I'm sorry, the side. The side that touches it is the adjacent, and this angle that's straight across here, that's the hypotenuse. Dead easy, yeah? So let's look at this one. Here we go. We have this one. Well, here's the long slanted side straight across from the right angle, so that has to be the hypotenuse. This is the side that touches our angle, so that has to be our adjacent, which means that this one, which is across from it, has to be our opposite. Okay? And if you understand which one, if you can label these, then there's nothing here you can't do. Right? Labeling is a critical piece. So we're going to give you a couple of those that you can practice. Now, if you notice these abbreviations that we're using, you need to use those capital letters and no others, because they're the key to making sure you know which trig function is which. Okay? All right, so I'm going to give you a couple of those for the homework, but not very many. The next key is here, Sohcahtoa. Now, here they have these little triangles, and if you've learned that method and you like that method, go for it. I hate it. It just gives you more to memorize. And there's really... Anyway, you know how I am. I like to do things very simply. So what I'm going to show you is Sohcahtoa. That's good. Where you just remember it. Okay? So we have So, Ka, and Toa. Exactly. Of course, being from the States, we were told that this was an Indian chief and his name was Sohcahtoa. The sillier it is, the more likely you are to remember it. And each one of these is one of the trig functions. The first one is something called the sine function. And I don't want you to get stressed out or even think about what these mean or where they came from or what they are. Don't even worry about it. You just need to know that it starts with S, therefore it's the sine function. And these, O and H, are those labels we gave the sides. So for sine, we're going to use opposite over the hypotenuse. So you're going to make a fraction for them, but you're just going to put them in exactly the order they come in the mnemonic device. So, Sohcahtoa. Give myself a little more room here. So, Ka is something called the cosine. And again, don't get hung up on those names. They're just Greek words that mean a specific relationship. They're just the name of this fraction is the cosine. And since we use A and H, that means that that's simply the adjacent over the hypotenuse.
Well, what about this? You can already write that down and alert
Okay.
Kelly and Calvin, hey.
And finally, the last one,
Like,
Toa.
shit, you're right.
That one is something called the tangent. And again, it's just its name. Don't get bogged down by it. And it is the opposite over the adjacent. Okay? So if you know what these labels are, and you use this mnemonic device, then you could do any trig function. Sohcahtoa. And those are the only three we're going to use. Now, they do have inverses, and we'll talk about those later. Perhaps, I'm not sure in right angle triangles if you use the inverses or not, but when you move to study trig, actually, if you move to study trig in level 2, you're going to find out that there are a few more trig functions, but these are your basic trig functions. Sohcahtoa. Okay? And all you're doing is just putting those things. So O over H, right? This one's A over H, and this one is O over A. Just making a fraction out of it. Now, okay, so let's look at, we're just going to find some finding the sine. We're not going to worry about their examples. We're just going to go down here. Okay, so here we go. Look at number 5. Okay, so here's our angle. Now, they're not using theta because in order to make these actually work, you have to know the measure of the angle. So there's our angle. And notice that we have an x and we have a 6. And I know nothing about this bottom side. So I don't care about it. Now, you could label it if you want to, just to keep yourself sane and remind yourself of what's going on. The x is on the longest side, so that's an h. The 6 is opposite the angle, so that's an O. Can't leave that arrow there. And that makes this the adjacent, but again, I don't care about the adjacent because there's nothing down there. So you're only interested in the ones that have values, okay? So your first step is to label the sides. Once you've done that, then you're going to decide which trig function to use. And if you look at this, I know an O and an H. Remember, I have so, I have ka, and I have toa. So the only one that uses O and H is so. So that tells me that in order to solve this problem, I'm going to be using the sine function. See how easy it is to tell? Label it, and then whatever letters you have labeled with your values, right? And they'll jump around. That'll tell you which trig function to use. So here's what we're going to do. The sine, and it's usually just abbreviated SIN for some reason, but it's called sine of the angle, so 48 degrees in this case, is equal to, and so is opposite, so in this case that's a 6, over hypotenuse, which in this case is an x. So then that'll allow us to write our equation. Okay, so write the equation. So whatever trig function we have, whatever angle we have, is equal to whatever pieces that made up that function. In this case, the opposite over the adjacent. And then it's just a simple equation for us to solve. Now your calculators are you cannot do this by hand, so don't even try. So the first thing is I need to clear the fractions by getting rid of that x. To get rid of the x out of the denominator, that means I need to multiply both terms by x. Over here they'll divide away, which gives me 6. Over here I have x times the sine, I have x times the sine of 48. Okay. Now, remember, my whole goal is to get that x by itself, and they're connected with multiplication, so the opposite of multiply is divide. So I'll divide both sides by the sine of 48 degrees, or the sine of 48. Your calculator will know that's in degrees. It should be in degrees. That will divide away.
Okay.
That gets me my x by itself.
Yeah.
And all I'm going to do is plug that into my calculator. And now remember, when you do that, you're dividing the 6 by the sine of 48, so put it in a bracket. Right? So do 6 divided by sine 48 degrees
I'll see you at the 2:30.
equals.
Okay,
And
bye.
that will give you your answer. Maybe I should have done one of the examples where I had the answer. But I want you to practice these keystrokes. So does somebody want to put that in your calculator and tell me what you get? Rounded to 2 decimal places? It's traditional. Okay, so you put that in your calculator, and rounded to 2 decimal places gives you 8.07. And that kind of makes sense because we were looking for our hypotenuse, which is going to be longer than this side, right? And so 8 is longer than that side. Now, they may not tell you to round it to 2 decimal places, but that's traditional, so that's usually what we do. Okay? So you're gonna have to use your calculator here. Okay? All right. So the calculator can do most of the math. You're just going to have to do a little manipulating to get it where you need it to be. Okay? Now, here, they're only doing sine, because this whole section is about sine. I don't want to only do sine, so I'm going to pop down a little bit. Now, the algebra can be different. That x can be anywhere. Okay? It'll never be here where you have the sine of the angle, because we're going to know the angle. But it could be in the top or the bottom of the fraction, which means that the algebra is going to look slightly different. Let's scroll down. Now again, they're telling you what you're going to be using, but it's not always the case. So let's look at number 7. I'm going to give you mixed exercises. So here we go. We know an angle and we know one side. If we know an angle and a side, that means that I'm going to have to use my trig functions to solve it. And so, remember, we have good old Chief Sohcahtoa. So, let's see what measurements we have that we know. Straight across from the angle, this would be the opposite, but I don't care about the opposite. Why? Somebody?
Because we don't have a value for it.
There you go. You don't have any value over there. There's nothing over there. So who cares? Okay, good job. So this long slanted side is the hypotenuse. So my hypotenuse is x. This side touches my angle. Therefore, it is the adjacent angle. So those are the two I care about. Now, sometimes they could give you a value here, which means you get to choose which one you'd like to use, right? But actually, if they gave you a value there, I'd use Pythagoras instead of, right? So, but they may give you more information than you need, in other words. So you may get to choose sometimes which trig function you use. So I have an A and an H. So is that so, ka, or toa?
Ka.
Ka, there you go, which is cosine. So the cosine of my angle, so 21, is equal to adjacent over hypotenuse. So my adjacent side is this one, so 3.9. Ooh, we didn't put units on that last answer too. We need to make sure you put units on the answer. Over x, which is now just a simple linear equation. So let's solve it by first clearing the fractions. So we'll multiply both sides by x to get the x by itself, or out of the denominator, I'm sorry. Then, so that leaves us x times the cosine of 21 is equal to 3.9. Now I need to get the x by itself, and to do that, we'll divide both sides by cosine of 21. And over here, they'll simply divide away, which gives you x equals 3.9 divided by the cosine of 21. And one thing I need you to do is I need to make sure that your calculators are in degrees and not radians, because you can be working in degrees, which is what we're working with. You can tell that because of the little symbol, and not what are called radians. That's another measure with circles that we don't want. And circles and triangles, just go figure. All right, so your calculator has to be in degrees. And I'm thinking that once it's reset, that the default is radians. So that answer we got a while ago might not have been entirely correct, but I think it was in degrees. I think it was fine. The number looked right. Okay, so you need to find out if your calculator is in degrees or radians, because it will have an effect on your answer. And we're going to use degrees, not radians. So somebody want to put in 3.9 divided by the cosine of 21 for me and tell me what you get?
4.17.
Okay, and of course we're going to put our units in this time. Now, that's only slightly bigger than that, but it is bigger, right? If you got a number that was smaller than that, then you'd be worried. Okay? Not bad, eh? Trig is easy once you remit, as long as you remember Sohcahtoa and how to label the triangles. So here we go. Let's see. Here we'll just look at number 2 for kicks. We haven't done an even one in a bit. So here's our angle. The one straight across from it is called the opposite, and this time I do care because it's got a value with it. This one right next to it is called the adjacent. So the one I don't know is the hypotenuse, so I don't care about it. So again, we have Sohcahtoa. And this one uses OA, so that's TOA. So it's the tangent of 54 degrees is equal to opposite over adjacent, which the opposite in this case is our x. Oh, that's nice. This one's going to be easier to solve even. And the adjacent is 14. The reason I say it's easier is because when we multiply by 14 to get rid of the fractions, our x is already on one side by itself. So all I have to do is put this into my calculator. 14 times the tangent of 54 degrees. And if somebody would do that for me, that would be wonderful. Anybody?
Um, 19.26.
Okay. Again, I'm not quite sure because there's that, but it's okay. Let's see. And can't really check this one because this one we don't know the hypotenuse, so it's going to be smaller. But it's a little bit bigger than that one, which makes sense, right? So it does make some sense. All right. Now, your job will be making sure you check them in the back of the book each time just to make sure. If you get the wrong answer, then you know you're probably not doing the mathematics wrong. You're probably in radians instead of degrees. Okay? So, let's just wrap up with the big ideas. Okay? Big ideas here. When to use the trig. We know one side and one angle. Trig is all about angles. Okay? So one side, one angle. Okay? How to label. That is going to depend on where your angle is. So let's say that this is our theta. Then straight across from it is the opposite. The side next to it is the adjacent. And that long slanted side is the opposite. Then, which function? And those are easy. You'll just remember Sohcahtoa. Oop, I can't spell. That's terrible. Toa. And that will tell you which trig function that you need to use. So those are the three keys here. How do I know to use the trig? Because I know one side and one angle. How do I label it? Opposite, adjacent, hypotenuse. And that will tell me which trig function as long as I remember Sohcahtoa. Now again, if you've learned the triangles and you want to use the triangles, I'm happy with that. It makes no difference to me. I am not the world's greatest math teacher, so it doesn't make any difference to me, right? You're not going to hurt my feelings if you do something differently. I just think that this is, to me, this one just made sense. And I was able to carry this Sohcahtoa with me for the rest of my life. And I never had to worry about, oh my gosh, which one is this? Which one is that, right? Which triangle is which? So it was just easier for me to remember Sohcahtoa, but you can remember the triangles if that's what you want to do, or indeed if that's what you've already done. I know that like Mrs. SM uses the triangles exclusively, but it makes no difference. It does mean there's a little trick to make solving the equation a little bit easier. Tough cookies. You're going to have to solve equations anyway, so you might as well get used to solving the equations because that'll help you also with the MCAT, right? So I'd really prefer you solve the equations. Now, so what I want you guys to do, the only assign part of this, because I'm not going to assign you any of those, I'm going to assign you finding the sides, mixing it up, which means sometimes you're going to be looking for sine, sometimes it's going to be tangent, sometimes it's going to be cosine. And in my mind, that just makes it stronger. It makes you a stronger person because you're able to decide not only how to label it, but then you have to find out which function to use, and you're going to be mixing them together, which makes it, gives you a little more challenge when you're finding these. Now, if you want to go back to the previous three exercises, the ones we use the examples for, and do some of those individually where you know it's going to be sine, you know it's going to be cosine, you know it's going to be tangent, that's perfectly fine. There's a lot more practice in there if you'd like it. But for me, I'm more concentrating on this. So what I'd like for you to do, these start on page 30, and there we go. So, and just 30 and 31. So not too many, but it'll give you a good practice, all right? So for the assignment, I want you to do page 30 through 31, and I'd really like you to do all of them so that you can get used to the solving. The only thing that can ever happen to you is you're going to get your x in the top over some number, which is nice because that means you just multiply both sides by the number, makes the algebra a little faster, or you'll get your x in the bottom under some number, which means you're going to multiply both sides by x, which then means you're going to have to divide to get the x by itself. Okay? So it's just a little bit of algebra that makes the difference between them. All right, stop the recording.